Hello and welcome to our number talk. Today we are looking at the expression 15 times 20. What we do in a number talk is we use mental math. It means no paper, no pencil to try to solve this expression, and then we look at all the different ways we could have figured it out. So before we go any further, let's go ahead and do that. Pause the video, figure out 15 times 20 in your head. When you have your answer, unpause the video, we'll look at all of our strategies together. So the first thing we could have done is we could have simply used this strategy of multiplying by multiples of 10, 100, or 1,000. And it's a really neat strategy that we need to use a lot. So let's take a look at our 15 times 20. Well, what we know is that 15 times 2, that's going to be easy because we're just going to double that. So that equals 30. So when we do 15 times 20, what we do is we simply take our non-zero digits, that's our 15 times 2, we multiply those, and then we add any extra zeros to the end. So it becomes 300. So hopefully that's the answer that you got. If you didn't want to use that strategy, I would suggest using the distributive property. This is our breaking apart property that lets us take one of the factors. So in this case, we're going to take our 20, we're going to break it apart into add-ins so that we can have some partial products. It just makes multiplying a little bit easier. Let's just kind of do it in chunks. So we're going to take our 20, we're going to reimagine that as a 10 plus 10, and then we're going to take our 15 and still multiply it by both add-ins, and that's what's going to give us our partial products. So really this is 15 times 10, and so 15 times 10 is going to be 150. And then we're going to add that to the other 15 times 10, and that's going to get us another 150. Add those together, you are going to get 300. So if we want to keep the distributive property, but we don't necessarily want to break up the 20, what we can do is we can take our 15 and we can reimagine that as place value. So think of 15 as expanded form. 10 plus 5. And we're going to take the 20, we're still going to multiply that by both of those add-ins. That's what's going to give us our partial products. So we're going to do our 10 times 20. And let's use that same strategy as we talked about on the first slide. So the non-zero digits are 1 and 2. Multiply those together, that gets you 2. And then add how many zeros you have left over. So there's your 200. 10 times 20 is 200. We're going to add that to this 5 times 20. And we can use that same strategy. 5 times 2 is 10. And add that 1 0, get you 100. 200 plus 100, there we go. That's going to get us back to our 300. We could also take the 15 and we could do it a little bit differently. It's going to get us the same answer. But let me just show you in case you don't always want to do it by place value. I want to break it up 15 into a 12 plus 3 just because a lot of us know our multiplication facts up to our 12s. And so if we can get into a 12, that usually makes it pretty easy. So let's take our 12, multiply it by 20. We know 12 times 2, that's 24. Add the 0, 240. And then we're going to add our 3 times that 20, and 3 times 2 is 6, so 3 times 20 is 60. We still add it up to get to 300. Same answer. But that's just a different way of looking at it. Now, doubling and halving can work if you've got at least one of your factors that is even. So we're going to take our 20, and we're going to cut it in half. So you see how we took it and we made it 10. So we're going to get rid of this 10 right here. So if we're going to take one factor and cut it in half, in order to maintain a balanced expression, we've got to take our other factor. We got to double it. That's why I've got two 15s. And so you double one, you have the other. Look at that. 30 times 10 is the same as 15 times 20. Well, that's super easy. 3 times 1 is 3. Add your two zeros. There you go. You got your 300. Now, We could also use the associative property. So that is our grouping property that lets us take a look at factors in different groups. So let's take our 15 times 20. We are going to reimagine our 15. We're not going to add it like we did with the distributive property. We're going to multiply it. 3 times 5. And so now I've got three factors. And once you have at least three factors, you can use the associative property to group them in different ways. So right now I've got my 3 times 5 because that's what I did to get 15. So let me just shift these parentheses. I'm going to regroup them. Look at that, 5 times 20. Same three factors, still multiplied all together. I just want to look at my 5 times 20 first, and that's what I've got right here. I've got 5 groups of 20. 1, 2, 3, 4, 5. Well, that's easy. 5 groups of 20 is 100. I've got 3 groups of 5 groups of 20. So I'm just going to skip count by 100s. Look at that. 100, 200, 300. Finally, what if we were to keep our 15 together and if we were to take our 20 and we were to break that up into, let's call it, we could do 2 times 10, but let's not. Let's call it 4 times 5. So our 20 is a 4 times 5 now. And what we're going to do is we're going to use our associative property again. And so instead of the 4 and the 5 being grouped together, I want the 15 and the 4. I'm just going to shift the parentheses. But I really don't want 15 groups of 4. I'd rather have 4 groups of 15. So I'm just going to flip those. And that's what this commutative property does. It is the order property. It just lets me switch the order of factors here. So I've got 4 groups of 15 times 5. And you know what? I want to use commutative one more time. I'd rather get 5 groups of 4 groups of 15. There we go. 5 groups of 4 groups of 15. So here's my 4 groups of 15. 1, 2, 3, 4. 4 times 15 is 60, and I've got 5 of those. So I'm just going to skip count by 60s. 120, 180, 240, and my 5 times my 60 gets me down to my 300. So if you found another way, that is fantastic. Go ahead and drop that as a comment on the video. Teachers, if you would like a copy of the slide deck for your own use in the classroom, you can find it on my website, 5minutemath.net.